Hai, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Afiq Azri bin Sulaiman. 11 DKM 19 F1022. Next.
Okay, nama saya Arif Zafran bin Osman. 11 DKM 19F1058.
Saya Muhammad Alif Najmi bin Hazmi, nombor metrik 11 DKM 19F1052.
Okay, hari ni kita akan menerangkan tentang lab. Saya dulu. Share screen. Nampak kan share screen aku? Tak nampak, tak dengar Mat.
Nampak.
Nampak bos.
Apa dia? Ada di dalam lab fundamental of static. Okay. Experiment outcome at the end of the lab session, students should be able to investigate the weight of body in kilogram and convert it to Newton. Then, number 2, determine the load need to the real weight by using Coulomb concept. Changing of kilogram kg to Newton is scale of 10 to 1. Okay, pulley concept, a fixed pulley or class 1 pulley is a fixed cell, which is the cell is fixed or active. A fixed pulley is used for detection of force. The fixed pulley has a mechanical advantage of one means that the force is equal on this. Ini contoh fixed pulley. Okay. Point 3, pulley concept with distance. Example that apply is Newton. The effect C can be calculated by dividing load at L to load T times 100. So, kita convert equipment dia, holder, rope, hook, weight slash load, marker pen, accurate weight equipment. The process any equipment without actual permission, do not conduct the experiment without supervisor. Provision of the lecture. After finishing experiment, please arrange procedure dia. Take your weight by using accurate weight equipment before you start the experiment. Jot down the data on table 1. Ensure the data is measured in Newton. Set up the practice for doing the experiment by taking the pulley concept. Make an equilibrium state for the fixed pulley as your data weight. Start the experiment by taking the data scale of 10 to 1. That's the starting point of the pulley. Then measure it until 60 cm. Then start adding the additional load on the left side. Result data kita dapat. Okay. Discussion. Dia tak coba. Okay, jawapan dia biru lah. Soalan dia hitam. Load need to move your static position. Is one of your team could move you? Yes, totally. The effect C of experiment, what is the cause of low or high of this percent, how to improve the effects static and dynamic equilibrium to the number 3, the do and don't while doing the experiment. 2. Make sure the loop is in a straight line. 4. Do not use a rusty tool or in fact the experiment. In this experiment can be accepted. Why? How to improve this experiment. Yes, the experiments will work forcefully works good with load and some of the machine need to work the experiment with that. That is a point of equilibrium that makes things move quickly and easily. Conclusion: some pulley is an important effect in mechanical engineering. Pulley is one of 6 central machines used to lift weight. Pulley are assembled as part of belt and chains drive in order to transmit power from rotation shaft to other. Okey, itu saja. Terima kasih untuk lab 1.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Azli bin Hamsan daripada kelas DKM 3B 11 DKN 19F 1031. Hari ni saya nak membincangkan tentang lab yang bertajuk Hooke's Law Static. So tajuk mula Hooke's Law Static 2.0 outcome iaitu student can understand the basic of Hooke's Law. Student can find the spring constant of 3 springs with different initial. Student can know and use the equipment for the experiment correctly. Student can list down and explain any safety precaution that apply during experiment. Student can brief an explanation of equipments, do and label the equipments. Student can write in passive sentence about all the steps taken during experiment. Student can discuss or answer given question. And lastly, student can make a conclusion based on experiment data or output. 3.0 is theory, iaitu Hooke's Law statement. The restoring force acting on an object is proportional to the negative of the displacement or deformation of the object symbol. F equal negative kx in bracket 1, where F is the restoring force provided by whatever is being stretched or squeezed. X is the displacement of the thing being stretched or squeezed. K is the constant of proportionality. The negative sign is important and just say that the restoring force is opposite in direction to the displacement. For example, if a spring is stretched by something in a certain direction, the spring will exert a restoring force at something by the opposing direction. Equation 1 also said that for an object which obeys Hooke's law, the more it stretched or squeezed, the greater will be the restoring force supplied by the object or whatever is doing the stretching or the squeezing. An applied force F acting on our Hookean object will cause to be displaced by some amount x. The ratio of the change in applied force and the change in the resulting displacement is called the spring constant K, and can be written as follow: K equal F equal x2, and the equipment, set of spring, set of weight, and meter ruler. Procedure: first, for each trial, determine the initial length of the spring. Record the final length of the spring and the mass used: 5 Newton, 10 Newton, 15 Newton, 20 Newton, 25 Newton, and 30 Newton. Repeat the experiment by changing the mass of hanger. 3. Find Kx, the experimental spring constant for each trial. 4. Repeat the experiment by changing the spring. Find the value of K value for all the 5 spring. Result and data observation: spring 1 and digit, spring 2 and analysis, spring 1, spring 2. Find the slope of each graph. Spring 1 2.8571, spring 2 0.0016. Find the average value K for each spring and compare it with the graph slope for each spring. Spring 1 95.541, spring 2 73.7. And this is discussion. Hooke's law is a principle of physics that states that the force needed to extend or compress by a spring by some distance is proportional to that distance. I keep it simple and keep it short. And Hooke's law is the first classical example of explanation of elasticity with the property of an object or material which causes it to be restored to its original shape or distortion. Still in general form, Hooke's law is compatible with Newton's law of static equilibrium. And that's the short form for my discussion. And 9, conclusion and recommendation. Hooke's law says the stretch of a spring is directly proportional to the applied force. In symbol F equal Kx, where F is the force, X is the stretch, and K is a constant of proportionality. If Hooke's law is correct, then the graph of force versus stretch will be straight line. In this experiment, the stretch of the spring changes as the force applied on the spring changes. As the stretch increases, the force increases, and it is a constant increase. During the conduction of this lab, several new phrases that were defined came up. Extension, Hooke's law, the spring constant, the person different. Extension is the stretch of the spring, how far it stretches. Hooke's law is a principle of physics. It states that the force needed to extend or compress a spring is proportional to the distance stretches. That is a linear correlation. And then lastly is reference. So thank you.
Memang ni memang lama sikit. Dah siap yang kau record tadi.
Jangan, aku dah record tu.
Okay. Now kita sambung ke lab number 3. Let's go.
Oh, sepatutnya tak payah screen record kan? Tak payah screen. Oh, share screen.
Tak ya? Okay. Nampak record? Screen record?
Nampak.
Okay, mantul. Lemak. Okay, let's go. We go to lab number 3, velocity and acceleration. Okay, experiment outcome. At the end of the experiment, the student should be able to 1. Analyze critically the experimental data in relation to the theoretical aspect. Number 2. Organize appropriately electrical and engineering mechanics experiment in group according to the standards of procedure. Number 3. Write critically the appropriate report and group based on the experiment result. Theory. Number 1. Speed. Speed is the rate of change in distance. In other words, it is how fast the distance changes in 1 unit of time. In mathematics, displacement can be calculated from the following formula. Speed equal to distance over time, divide time. Like that. We need meter second. Meter per second. Type of quantity, scalar quantity. Number 2, velocity. Velocity is the rate of change in displacement. It is how fast the displacement change in 1 unit of time. Time over displacement divided by time. Unit meter per second. Number 3, acceleration. Acceleration is the rate of velocity change. Acceleration is a vector quantity formula. Oh, acceleration equal to final velocity minus with initial velocity divided by time taken. Unit meter per second squared. Time of quantity, vector quantity, an object moves with a constant velocity if the magnitude and direction of the motion is always constant. An object experiences changes in velocity if the magnitude of velocity changes, the direction of the motion changes. Equation for uniform acceleration. There is a four equation. The above equation is for solving numerical problem involving uniform acceleration. We go to the number 3, apparatus or equipments. Number 1, pulley. Number 2, set of weight balance. Number 3, string. Number 4, inclined plane and sliding friction. Number 5, meter ruler. Number 6, spring balance. Number 4, procedure. Number 1, step 1, set up the apparatus and material as shown in figure below. Second step, set an inclined plane and sliding friction at 45 degree. Step 3, pull the hook with load 9 Newton and record the time when the load falling down on inclined plane and sliding friction. Step 4, repeat the experiment with different weight, at least 4 different weight. Step 5, record the result table below and sketch a graph load Newton versus time. Like we see, number 5, safety precaution. Ensure to put the load properly so the experimental accident could be prevented. Safety shoe is advised to be worn as the experiment is deal with loads. Number 6, result or data. We got a two material aluminium with a distance for 0.4 meter. So you can see the data from the load aluminium material. And the second, we got a bronze material. And then the discussion from the result, sketch a graph load meter versus time. Oh, load versus time. So we can see load versus time with the aluminium material and bronze material. The next one, conclusion and recommendation. Velocity is the rate of change of position with respect to time. Whereas acceleration is the rate of change of velocity. Both are vector quantity and so also have satisfied directions. But the unit of velocity are meter per second, while the unit acceleration are meter per second squared. When the load changes velocity with accelerate, acceleration is the change in velocity per second and is measured in meter per second squared. The relationship between acceleration, velocity change, and the time second for the changes is given by this formula. That's all. Thank you, both. Alright.
Angah yang perempuan kan? Bukan nama tu. Salah.
Mana ada Angai perempuan siap?
Dah record.
Alip ada? Oh, dah rekod dah.
Alif. Oh, saya pada rekod tu.
Okay, Assalamualaikum. Saya Muhammad Ali Najmi bin Razmi. Nombor matrik 11 DKN 19 F1052. So hari ni saya nak terangkan tentang lab engineering mekanik. So experiment outcome, at the end of the experiment, the student should be able to investigate the theory of conservation energy in system of energy transition. Number 2, know and use the equipment for experiment. So kita pergi pada teori. Teori dia, the concept of energy is one of the most important topic in science and engineering. This is because every physical process that occurs in the universe involves energy and energy transfer or transformation. For example, we use energy concept to lift off a plane and propel rockets. We perhaps inadvertently experience a transfer of energy whenever we watch television, listen to the radio, or blow the overhead. It is also important to note that energy can be neither created nor destroyed, but only transferred from one source to another. This concept, known as the conservation of energy, is the basic for this lab. Our goal is to verify the law of conservation of energy by proving that in a particular system, in this case, the motion of a pendulum, the energy is conserved. That is, as long as no outside force act of on the pendulum, that the energy in the pendulum system cannot be lost or gained. The idea of energy can be traced to Kepler or in the 7th century. He noticed that when a weight is lifted with a pulley, the force applied multiplied by the distance to which that force must be applied remains constant even though either factor may vary. This concept vis viva was also shown to be directly proportional to the product of the mass and the square of the velocity. Later in the 9th century, the term energy was applied to the concept of vis viva. Today we may recognize Galileo finding by the formula where work is equal to the change in kinetic. Since kinetic energy equal one half the product of the mass and the square of the velocity, it can be seen that Galileo was correct when he claimed that work is proportional kinetic energy. So ni adalah contoh formula je, where PE is potential energy, M is the mass of the object, G is defined acceleration due to gravity at 9.8 meter per second square, and H is the object height with respect to a chosen reference point. So ni adalah teori-teori yang lain. Formula je 1, 2. Kalau ni solving for velocity give us. So 3.0 apparatus equipment. Nombor 1 weight. Berat dia 5 Newton dengan 10 Newton. Load mounting. String meter ruler. Procedure dia tie up neatly the load mounting which has same length and same weight, and allow B load mounting vertically while a load mounting rod as in figure 1. Measure the H1 distance between the load burden and record into table 1. C release the A load mounting and let it hit B load mounting and measure the level of vertical B load mounting. That it has H2 and record in table 1. Repeat twice step 1 to 3 for different values of H1. Get the mass of both load mounting. Repeat step 1 to 5 for the different mass of weight and record the reading into table 2. Calculate the potential energy produced by the weight of A and B in the table and determine the energy difference. E energy in unit of Nm Newton meter or joule. So ni gambar jalan tu. Safety precaution dia. Please do not conduct the experiment without supervision of lecturer. Measure the student wearing a safety hose. Safety shoes. Arrange all the equipment when finish the experiment. 6. Result data. So kita dah dapat, dia tahu kita punya, dia punya mass A dengan mass B iaitu 0.72 sama je. So ni contoh bila kita dah buat eksperimen tu, kita dah dapat nilai, kita masukkan saja nilai dia untuk kira H1 dengan H2. So discussion, what is the relation between H1 and H2 for the same mass? H1 value is equivalent to H2. The relation between H1 and H2 with the same or different mass is directly proportional to each other. Number 2, explain whether S2 will depend on mass or H1. S2 depend on H1 since it is directly proportional to each other. Itu adalah formula gap. Nombor 3, give your comment about the amount of energy obtained from the experiment and justify the reason why it occurs. The quantity of energy obtained from the experiment is not correct. Since the energy obtained from the experiment, it is possible to achieve 100% efficiency in energy change because energy does exist during the phase of acceleration. Conclusion and recommendation. The energy conservation theory states that energy is neither produced nor lost from one kind to another. It can transform to validity of energy conservation depends on scientific finding, much like the theory of mass conservation. It is therefore an empirical law. So 9 reference rujukan worksheet dari Principle on Conservation Energy. Ini adalah website yang kita buat sebagai reference. So itu saja, sekian, terima kasih.